All right, good morning, everybody. Rub the sleepies from your eyes. We're hitting it completely different today for an investigation. Welcome to Investigation 5. We are all about organizing and analyzing data. So, today's Socrative will be most of the investigation. You're only going to need paper and pencil for one question. Make sure you pay attention to everything carefully. I'll explain each section. Then you hit pause when I tell you to and answer the questions I ask you to in Socrative. And this is going to be your grade. So go slow and careful. Don't be afraid to rewind if you don't understand something. Take a deep breath, and are we ready to hit it? So, to start off with, teachers collect information about your attendance, your homework scores, and your test scores, and the school gathers up information about the class sizes, the lunch counts, the bus routes, and supplies the order. Sports teams compile information about wins and losses, the points you score, the points you may allow the other team to score, any errors made, etc. Anytime you're gathering up a bunch of numbers, these types of numbers are called data. And the study of data is called statistics. So the first thing we want to talk about in this study of data is frequency tables. And what you got to know about this whole data thing is that newly gathered data, meaning the numbers, it's always going to be unorganized. And to be useful, statisticians have to organize it some way to make it useful, so you can understand it quickly without having to read all the numbers. So, two ways of first organizing collected data is with frequency tables that we're going to talk about first and line plots. So, what if we had something like this? Mr. Hines gave a group of 25 students a choice of 6 different activities. They could choose to do either activity 1, 2, 3, 4, 5, or 6. And here's a list of the activities chosen. Out of those 25 kids, one kid said, I'll do activity 4. 2 kids wanted to do 3. One more kid wanted to do 4. One kid wanted to do activity 2, and so on, and so on, and so on. This is that unorganized numbers, the unorganized raw data. So if they asked you something like, which activity was picked most, you're going, are you kidding me? Or which activity was picked the least? Yeah, well, if I couldn't figure out the most, I really can't figure out the least. So we got to get it organized somehow. And one way to do that is to make a frequency table. It's going to be a rectangle. There's always going to be 3 columns in it. The first heading on the left-hand side is the title of whatever data you're sorting. In this case, we're figuring out the activities. The other 2 columns will always be labeled tally, and the last one is always going to be labeled frequency. And the whole column on the left-hand side is going to be the names of the different data that you're trying to sort. Remember, here is our raw data collection right here. So we better get ready to start sorting it. I'm going to start off with my first 3 numbers, a 4, a 3, and a 3. So the first thing we want to do under the tally column, I had a 4, so I'm just going to put one little line there, and then 2 3s. So we all know how to make those tally marks, right? Now I have a 4, a 2, and a 5, so let's keep making tally marks. 4, 2, 5. Now I have 6, 1, 3. So 1 in the 6, 1 and 3. Now I have 4, 5, 2, 2. I'm going to go a little bit faster. 4, 5, 2, 2, 6, 3, 3, 4, 6, 3. Uh-oh, one more 3. Remember when we're at 5, we tally them. And then one more in the 4 column. 3, 2, 4, 5. 3, 2, 1 across because that was 4. And then 1 down here in the 5 column. And lastly, we have 3, 5, 5, 6. So 3, 5, 1 more across in 5, and 1 more in 6. So I have my tallies. The last step now is to convert your tallies into numbers, the actual frequency that it happened. Well, I only have one tally for 1, so that's a 1. Over here in the 2 column, I have 4 tallies. Over here for 3s, looks to me like I have 7. Under 4, looks to me like I have 5. Here it looks like I have 5 more. And under 6, I have 3, right? So I always like to go and add them all up and make sure I didn't make any mistakes. So 5 and 5 is 10, and 7 and 3 is 10. So I'm at 20, now 24 and 25. And I know I had 25 numbers because it said 25 students, right? Always double check on your frequency table and make sure that you have everything accounted for. So now that I have that all accounted for, it's a whole lot easier to answer questions about the data now that it's organized. So like, how many kids chose activity 6? Well, that's a piece of cake. 3 kids chose activity 6. Which 2 activities had the same number of students? Which 2 had the same number? Activity 4 and activity 5, right? So I could just label it 4 and 5. Which activity was chosen the least? Only one kid wanted to do activity 1. Which activity was chosen the most? Looks like activity 3 was the most popular. 7 kids wanted to do activity 3. And how many activities had 5 or more students? Well, that's 5, and that's 5, and 7 is more than 5. So they say, how many activities? What do I got here? Looks like 3 different activities. That's how many activities, right? So now I want you to stop and hit pause. Do problems 1 through 3 in Socrative. All right, welcome back. Now we're going to go and talk about the other way to organize some raw data. These are line plots. So if we wanted to see each data point, you can always make what they call a line plot. 2 steps to a line plot. Draw a number line that includes the highest and lowest number in the data set. And then you got to go and put an X above each number on the number line that corresponds to each number in your data set. And the data set is just always the raw, unorganized data that doesn't make any sense. So right now I have a data set over here consisting of 3, 4, 1, 3, and 5. The smallest number I have is a 1. The greatest number I have is a 5, right? So I drew a number line. I wanted to make sure that it includes my lowest number and my highest number. Let's just start putting X's. My first piece of data up I have is a 3. So I'm just going to draw a little X right there. Then I have a 4, and I'm going to put a little X on top of 4. Then I have a 1, so I'm going to go over to 1, put a little X there. Then I have another 3, so I'm going to put that other X. I'm just going to stack them up. And then I have a 5. And you can always go and keep stacking your X's. Look how many X's we had in this one, right? That is all there is to making a line plot. So there's a lot more vocabulary though. And all this vocabulary, I'm going to go through it all, but on the Socrative, when it's time to answer the questions, I highly recommend having your book open at page 320, and most of them are also found in your glossary. So when you're making line plots, they sometimes talk about a cluster. And a cluster is just a group of data points that are very close together. And there can be more than one cluster. In this case, I have a cluster right here. Which 3 numbers represent the cluster? Well, if that's 10, this must be 11, 12, and 13, right? So which 3 numbers represent the cluster? 11, 12, and 13 are the numbers that represent the cluster for us. Not too tough so far, as long as you remember what the words mean. Another piece of terminology, this time it's called an outlier. And an outlier just means a data point that is distant from the majority of the other data points. So here I had a cluster and I got some more X's over here, and it starts thinning out. And way over here, all by himself, he's lying out yonder, out by himself. This guy would represent an outlier. So if they asked us which number represents an outlier, what number would that be? If this is 20 and this is 25, they're not all labeled, but do you know the number? Yeah, that's pretty easy. He's 21. They might ask you to use your organized data set now to answer questions like, how many people were older than 20? Well, right here is 20. How many were older than 20? I only have 2 X's there, so that must mean 2 people. Take a look at number 2. Which ages were recorded twice? Meaning you have 2 people the same age. Where do I have 2 X's? It looks like I only have 2 X's right here. So which age was that? If he's 1 on the left-hand side before 10, that must mean 9 was recorded twice, right? Check out number 3. How many people were between the ages of 10 and 15? Between the ages of 10 and 15. Am I actually going to count 15? No, I'm not. They want to know which ones were between those ages. So we're talking about all these guys. So I have 3, 4, 5, 6, 7, 8, 9, 10, 11 people were between the ages of 10 and 15. So still more terminology on page 320 of your book. We are talking about the mode. I have to track that on our test scores a lot, right? I've talked about the mode to you before. And the mode of a data set is the number that occurs most often on a line plot. It's going to be wherever you have the most x's stacked up. So if they're asking us what's the mode of this data set, well, the mode's right here, right? So here's 10, here's 11. So the mode of this data set would be 12. So now that we know that, let's go and apply it. What is the most frequent age or the mode of the people who were tracked? We just got done saying it before. It is 12. Look at this one. How many people are tracked? Well, how many x's do I have here? This looks like 4 plus 3 more makes 7. Plus 5 more makes 12, plus 3 more makes 15. I'll add on these 3 to making it 18. And the final 2 looks to me like I'm tracking 20 people. And I'm going to do one more, same like the other one. How many people were between 15 and 20 years old? Remember, if you're talking about between, you actually don't want to go and count those numbers. How many people were between 15 and 20? That would be 2. So one more piece of vocabulary for us. Now we're talking about the range. And the range of a data set is the difference between the greatest and least number in a data set. And remember, if we see this word difference, that means we subtract. So the least or the smallest number that we have is right here. What number is that? If this is 5, 6, 7, 8, the smallest or least that we have is 8. Over here is our greatest number, right? Well, if this is 20 and that's 21 and that's 22. Now it's simply a matter of subtracting the greatest from the least. So 22 minus 8, if they want us to find the range of this data set, that's going to give us 14, right? That's not too tough. You find the biggest number in your data set, you find the smallest number in your data set, and you find the difference. You subtract them. All right, let's check out this one. I talk about it a lot with our test scores. The median of a data set is the number in the middle if all the numbers are ordered from least to greatest. That's the tricky part right there. So if they're asking you what the median of the data set is, the first thing we got to do is list all the numbers out in order. So if we're taking a look at our data set right now, the first number that I have 1x right there. What number is that? If this is 5, 6, 7, 8, right? So let's start with an 8. Now I have 1, 2, 3, 9. So I'm going to go 9, 9, 9. I have 3 11s right here, right? So 11, 11, 11. Now over here I have 12, and it looks like I have 5 of those. So 12, 12, 12, 12, 12. And lastly, it's looking like I have 3 more 13s. So 13, 13, 13. So there they are in order from least to greatest, and I gotta find the number in the middle. I'll give you a little hint. If it's an odd number, makes it kind of easy. So do I have an even or an odd number here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yay! It is odd. So all I'm going to have to do to start off with is divide by 2. What would be 15 divided by 2? Well, technically, it's 7.5, and we don't really care about the half right now. I want to focus on this whole number 7 because that's going to help me find what my number in the middle is. 1, 2, 3, 4, 5, 6, 7 on this side. And let's go to the other side. 1, 2, 3, 4, 5, 6, 7. So I have 7 on this side, I have 7 on this side. Our median number, our number in the middle, hey, that's got to be 12. You have to list out the order of, you have to list out the numbers in order from least to greatest and find the number in the middle. And it's pretty easy with an odd number. I'll show you what to do with those even numbers here in a moment. So right now I want you to hit pause and start doing problems 4 through 15 now in Socrative. All right, welcome back. So we've seen the way to organize the data. Now we're going to start talking about how to display your data. And the first thing we're going to talk about here is called pictographs. And all of these next 3 are all types of graphs. And a graph is just a diagram or a picture that shows data in an organized way. And a pictograph uses pictures to represent the data set. The key to any and all graphs is always read the key. What are they trying to show you? Well, the title is Dinner Served. And one of these fancy blue dishes represents 10 dinners. You're not thinking 4 people ate dinner on Tuesday. Each one is 10. So 10, 20, 30, 40 people ate dinner on Tuesday. Another 40 people ate dinner on Wednesday. 50 people ate dinner on Thursday, and so on and so on. So let's take a look and see how our organized data is going to work now. Even though they give you the key and they have pictures that represent, I always highly recommend just writing in the numbers so there's no confusion. So Tuesday we had 20, and on Wednesday, looks to me like there was 40 people having supper, and on Thursday there was 50 people having supper, and we had 20 people on Friday. We had another 20 people on Saturday, and we had 40 people eating supper on Sunday. So our first question up right now, they are saying how many people ate dinner on Tuesday and Sunday. Well, that looks like an adding problem. If I had 20 people on Tuesday and 40 more people on Sunday, that looks like I had 60 people eating dinner, right? Take a look at question number 2. What is the mode of the number of dinners? Well, the mode is the number that occurs most often. If I have the numbers written down, it's pretty easy to spot that my mode has got to be 20, right? That's the number that's showing up most often. And now for the median. If we take a look, remember median, we have to put the numbers in order, first of all, from least to greatest. So my least smallest number, I have 3 20s there, right? So I'm going to go 20, 20, 20. My next smallest numbers that I have is going to be 40, 40, and then 50. So let's go ahead and just write that in after that. 40, 40, 50. And 50. So there are my numbers organized from least to greatest. Here is a problem. Not really a problem, but something that's different. I have an even number here. Remember, we have to find the number in the middle, and if you have an even number, you don't really have one number in the middle. So if there is no number in the middle, you got to add the 2 in the middle and divide that by 2. I have 20 and 40 in the middle of my data set. So 20 plus 40 is 60. And then you got to go and divide that by 2, we say. 60 divided by 2, hey, that's going to give us 30 for our median then. So the median of the data set is 30 because I got to take the two numbers, add them, and divide by 2. So I now want you to hit pause, and I'm going to want you to complete problems 16 and 17 in your Socrative quiz. All right, welcome back. One more way of organizing and displaying our data is with bar graphs. And a bar graph uses bars to represent the data set. As always, the key to success is reading the keys and the scale. Make sure it looks like our lines are going up by 2s this time, right? My title is trying to tell us what kids' favorite school lunches are. This is the number of students and pizza, hamburger, spaghetti, salad. I don't run into too many 5th graders who don't know their way around a bar graph. So let's take a look. Number 1, what is the least favorite lunch? So I'm looking for the shortest bar. Looks to me like my least favorite lunch would be spaghetti. How many students liked pizza best? Well, here's my pizza bar. Uh-oh, I don't have a number right here. It's halfway in between 8 and 10. So we should be able to figure this one out. That must be 9 kids liking on the pizza the best, right? Check this one out. Is it true that the number of kids who like pizza best, which we said was 9, is 9 greater than the number of kids who liked hamburgers and spaghetti combined? Well, we know that 9 kids like pizza best. So is 9 more than hamburgers and spaghetti combined? Let's find out how many kids liked hamburgers. And if I combine them, I'm going to go and add. And spaghetti, one of those tricky ones again, it's not right up to the line. It's halfway in between the 4 line and the 6 line, which must mean it's 5. So now that we have that, 6 plus 5 is 11 for hamburger and spaghetti combined. So is it true? No, it is not true. It is most definitely false because 11 is greater than 9. So now I want you to hit pause. I want you to do problems 18 and 19 in your Socrative, please. Moving on, welcome back to line graphs. And a line graph uses lines to represent how the data set may change over time. All those other graphs aren't showing time. We need a line graph if you're plotting anything and you want to show how it changes. So We have one here that's titled The Flight of a Model Airplane. You want to read the keys and the scale. This is the time in seconds, and it flew up into the air, and then it flew even higher, and then it started going down, hit the ground after 70 seconds over time. So a few words I want to point out to you. When it starts going up, that's being referred to as the ascending. That word ascent means to go higher. Here is its constant altitude, when it's staying the same. That's what that word constant means. Here's more ascending altitude, and the highest point, that's the maximum altitude. And now it starts its descending altitude run. Descending means it's going lower. So now that we know that, what was the height of the plane after 20 seconds? Well, here's the time, 20 seconds. Let's go up. The height of the plane appears to have been 40 feet, right? And now they want to know, for how many seconds during the flight did the plane fly at a descending altitude? Well, descending, I'm starting here, and I'm hitting the ground here. Don't sit there and say 70 seconds, because I actually have to start this as 0, right? And now this would be 10 seconds. Over here would be 20 more seconds. Finally, how many seconds did it fly in a descending altitude? Looks to me like it spent 30 seconds descending, going down. Stop! You are almost done! Yay! So I want you to do problems 20 and 21 in Socrative, because that is the end of our video.